Hello everybody, welcome back. Today we're doing 3.6 polynomials of the form ax squared plus bx plus c. So the difference between the last section, 3.5 and 3.6 is now we have a coefficient in front of the x squared. So we can have two or more of the larger tiles or the x squareds here. So these become a little more complicated when we're trying to factor these, but we're going to use some of the similar strategies with a little bit of manipulation on one of them in order to do this. Okay, you can try to draw that if you wish. Take these tiles and see if you can make a rectangle with these. You're going to notice that you're not able to use all of them, unfortunately. So you just do the best you can with the most tiles, and you can try that if you wish. Okay, and you can use the program that I sent you that I'm going to put in the Google Classroom for the digital algae tiles. All right. So let's use algae tiles to represent this. So the one side is 3D plus 4, and the second side is 4D plus 2. So let's arrange those tiles using our program. So if you do recall, what we need to do is we need to have one of our side lengths to be 3D plus 4 and the other side length to be 2D plus 2. So in order for that to happen, well, this means we'd have an X and an X here. We have an X here, here. Okay, so that'll give me 4 Ds along the top. And then I need the one side's ones. So those are side 1 and 1. So this up here would be 4D plus 2, or we have X's. It's the same thing, obviously. So it's equivalent. So then we need to have 3 going this way. So we fill in here. Okay. So this side here is 1, 2, 3 Ds. And then we need the ones. So we take these tiles. And what we're going to need to do is we're going to need to rotate them. So there's this rotation button here. Just click on them and it'll rotate all of them. Then go back to your arrow, and that allows you to start moving them. Oh, sorry, what? Here we are. Okay. And what we need to do is we need to fill in with the rest. So we're going to need a lot more of these. So 1, 2, 3, 4 more over here. Then we're going to need 8 more over here. So we'll go 1, 2, 3, 4 first, so it's not too crowded. Rotate them. Hit your arrow back to get them to move them. So there we are. And then we need 4 more. 1, 2, 3, 4. Let's rotate them. Arrow back to put them in the right location. And then we're going to need even 4 more. I think I said 8 before, but obviously I was wrong. 1, 2, 3, 4. Okay, click this button here, rotate them. 1, 2, 3, 4, and take it off to do that. And then we need the ones to fill in the rest. We got 1, 2, 3, 4. So there's 1, 2, 3, 4. I need 4 more. 1, 2, 3, 4. And there we are. Now your book is just using D instead of X. It's equivalent, right? It just means you're unknown. Okay. So what we'll do is we'll take a picture of that so I can put it in my question there for us. And there we can represent it in the first method using the algae tiles. All right. Sorry about that. And there's your algae tile representation. Make that a little smaller. It doesn't need to be that big. There you are. Okay, so that means that this side is 4D plus 2. And remember, X's is just because that's what our algae tiles use. Right, because we got an X, 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 so there's 4 X's, and then 1s, these sides are 1s, right? And then This side here is 3D plus 4. 3D plus 4. Okay. And there you have it. So all we do is count them all up now to get the total. So that means that if we expand this, we have 3D plus 4 multiplied by 4D plus 2. That means it's going to equal 12D squared. Right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12x squared, so we'll just represent that with a D. Plus, and then how many x's we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So that means we have 22 D's, or x's. I mean, like I said, it's just the unknown. I don't know why the book is using x's. I guess to show that it doesn't always have to be x. And then how many ones do we have? 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So when we expand this, 3D plus 4 multiplied by 4D plus 2 is equal to 12D squared plus 22D plus 8. Okay? A rectangular diagram is another okay method. Our goal is to move to the distributive property. That's what we'll need for to do it algebraically. But if you're doing the rectangular method, I'll show you what that looks like. So the rectangular diagram is similar to what we did in the previous video. We break it up into terms. So we have 3D is one term and 4 is the ones term. 2D is the x term and 2 is the one term, and then we just multiply. So 3D times 4D is 12D squared. 4 times 4D is 16D. 3D times 2 is 6D, and 2 times 4 is 8. So there's your 12D squared, and there's 16, and your 3D come together because they're like terms, and that's 22D, which you see right here, plus 8. So it's done in a similar fashion. It's the same thing, right? In there, what we're going to do is what's called a distributive property. The distributive property is a method that we're going to take with us, and we're going to use the most algebraically. These other method 1 and method 2 are just to help you maybe see it, but I'm going to show you the distributive property, and this is a method that we use, like I said, the majority of the time when we're solving these questions in mathematics. Okay, so I'm just going to scroll that down for a minute and show you how that works. And again, it's similar to what we did in the previous lesson. Like I said, we did this already in the previous lesson, but we're going to reiterate this. You would have done this in grade 9. All right, so just bear with us when we're doing that. So remember, when we're working with the distributive property, that we have to multiply the first term in the first binomial by the first term in the second binomial. So it's going to look like 3D times 4D plus, and then we do the first term in the second binomial, or first term in the first binomial by the second term in the second binomial, so it's 3D times 2, times 2, and then we plus, because there's a 4, it's plus 4, right? 4 multiplied 4D multiplied, 4 multiplied by 4D. So then it's the second term in the first binomial by the first term in the second binomial plus, and then it's the second term in the first binomial 4 plus the second term in the second binomial 2. And remember, if anything's negative, make sure the negative goes with. These were all positive, so it works out really nice. Okay. So this is going to equal, when we multiply these together, we get 12d squared. 12d squared. When we multiply 3d by 2, we get 6d. When we multiply 4 by 4d, we get 16d. When we multiply 4 by 2, we get 8. And then we have to combine any like terms. So the two terms here in the middle, 6d and 16d, are like terms, as we learned in junior high. So we add those two together, or even grade 9, and we get 22d plus 8. So same result. So these are great methods to show you, but this is the one that you're going to need moving forward in your mathematics stream. Is distributive property. Extremely important, and we need to know how to do that. Without this, it'll become very difficult. Okay? So that's how we multiply two binomials with positive terms. Let's look at the next example. In the next video, we'll do example 2, and we're going to multiply two binomials with negative coefficients. Okay? And that's where we're at. So in the next video, we'll take an approach and we'll look at that. Okay? You can try to check your understanding while before example 2 if you wish. All right? See you in the next video. Thank you very much.